Web UI concepts for business applications. This is a series of videos that we currently produce. Part one of the series considers life cycle considerations. My name is Björn Müller. I'm founder and core developer behind the Captain Casa UI framework. Well, let's start. So looking on life cycle of business applications, we see that it's long. Yeah, you start with development, you enrich function-wise, you adapt your product to customer needs, to legal conditions, to technical conditions. So if you look on all the phases that you run with your product through, you develop, you sell it, you use it at customer side. So you easily come up in cycles of 1 to 2 years to come up with the first product, then 8 years of selling, 10 years of usage. So making all together, summing up, you have something like 20 years of life cycle of your software product. And this is the life cycle where you have to support it, where you have to develop things, where you have to maintain things. So that's the scope that you are in if starting an application that you want to sell to customers. Well, now let's check what this means on the architectural aspects. And of course, it means that you have to carefully separate between these parts of the architecture, which you want to keep stable throughout the whole life cycle, yeah, and these parts of the architecture where you want to be flexible. If you come to holding data, keeping data, it's good if you have stable data structures over the life cycle, if you have a stable database. If it's coming to, for example, connectivity to outside, if it's a SOAP protocol, a REST protocol, whatever messaging protocol, there you are flexible. Yeah, so you have parts which are fixed and you have parts which you want to be flexible. Yeah, and if you now consider UIs, user interfaces, then same story applies. That you say, okay, you have different types of UIs. You have hundreds of dialogues in the area of employee operational usage. So these are the ones which are internally used. These are, I would say, the backbone of the processing, because that's actually where all the details are managed or can be managed. Yeah. Totally important for your application. Yeah. And these hundreds of screens that are internally used, these should be smart to use, nice to use, attractive to use, should be consistent throughout these 100 screens. So they should look very similar, the screens, to one another to make life easy for professional users. Yeah, they should be efficient. Sometimes they show a lot of data instead of presenting data step by step by step to increase efficiency. You should be flexible from navigation point of view. And of course, they should be performant, they should be fast, and they should be stable. So they should run a production in means of 7 hours, 7 days and 24 hours. Yeah. So there are other types of screen which are equally important, but have a different nature. Yeah, these are the ones you produce for anonymous end users, maybe customers of you, that you produce for occasional users, so some kind of self-service applications that you provide for your also internal users. And these have different aspects. These have to be eye-catching. There must be some wow effect. They must be up-to-date, modern. Yeah, they must be very simple to use. So if it's complex things, have to be separated into steps. Yeah, to tailor the information to the needs of the user, and there should be a strong guidance as well. Yeah, so that's the nature of these ones. Yeah, so both of them you have in your application, and if you come now to the lifecycle aspect, then of course the left ones, the operational usage ones, are the ones which are much more stable from lifecycle perspective than the right ones, where you have a more higher volatility of change, and people expect the change there also. So if you want to be attractive towards, for example, your end users, your end customers, then they are delighted to see some refreshing of designs, etc., every 3-4 years. So that's the situation. And this means on the left side, you carefully have to decide what to do as architecture for your application. Now, let's just check if you want to find an application architecture which is suitable for long-term support of user interfaces, then of course in the web UI, web environment, you are fighting with the number of frameworks which exist, and with the cycle that each framework has a phase where it gets born, where it's cool, where it's hype, and where suddenly it's replaced by another framework. Just looking, for example, at Google. Google has such a lot of frameworks rolled out. Google Web Toolkit, AngularJS, Angular without JS, yeah, which was completely different to Angular, Dart, and now if they have Flutter, so whatever. So just Google has more than 5 frameworks. This is a low number, which I mentioned, rolled out into the web community. And well, it means if you now decide for such a framework, and suddenly the framework is not on the cool side anymore, but it is replaced by another framework, then it's difficult. Yeah, you have your 20 years of life cycle, and the frameworks have something like 2, 3, 4, 5, 6, 7 years of life cycle. So there's a mismatch. So you have to somewhere find a way to decouple from this framework hypes and to have a stable architecture. And that's what your architecture has to be planned for. Now, how can you do such an architecture, and what is our experience to bring in? So we see that it's clear and a very nice advantage to really decouple all the rendering aspects of the application from the dialog processing aspects. What does it mean? Yeah. So if you, for example, imagine you have a browser with a rendering client, we call it, yeah, that this is a piece of software. Yeah, this piece of software running in the client. And this is pretty simply built. It is saying I am a machine, so to speak, which gets a layout definition from the server side. Yeah, that's what should I display, and then renders it and sends back events to the server-side application processing. So this means it is an abstracted communication. Here you have a layout definition, and here you have events coming from the rendering client. And on the other side, you have an application system in which you just say, hey, this is my dialog. Yeah, you define it by layout definition, and these are the reaction on changes of data and events in the layout. So let's look a little bit into details. So all this starts with the green box starting in the client of the browser. So this is a single page application from topology point of view. And this tells the server, hey, I'm now starting. So the server will respond and will tell something like, this is a layout definition, which is sent to the client side, and the client side renders this. Yeah. So the client does not know it all. What does it mean? Is it an article? Is it an order? Whatever. It's totally out of the scope of the client. This just gets, hey, this is an XML or a JSON or whatever layout definition. I render it. Yeah. So now the user sees the user interface, and the user can interact. And interaction means that at a certain point of time, the client has to respond to the server, or has to request to the server, hey, data changed. Yeah, so it sends some update protocol. In this field, a change. In this field, a change. There's an event, and this is sent to the server side, and the server side now processes this in its application. And what's the result of processing? It sends again the next XML layout definition. This time only the changes to the user interface processing. Yeah, and so on and so forth and so on and so forth. So you see, that's the architecture between a dialog processing server side and the client processing. And you also see there's a very strong decoupling of this. So on the client side, basically, you don't need application specialists. You need UI specialists. You need people who are well educated in all these UI technologies, HTML, CSS, all the web frameworks that exist, et cetera, et cetera. So this rendering client, you need some nerd, so to speak, to transfer a layout definition, which is coming from the application, and transfer this into a visible, into a usable UI, and send events back. On the server side, yeah, you have people who define what are the application dialogues. Yeah, so they are not interested in how is a field rendered now, which framework is used on the client side. They just define there is a field, and the field updates a certain data aspect. So that's the server side to control, to bring the data of the dialogues, the functions of the dialogue, into the application processing on the server side. Yeah, so this is clearly application skill oriented. This is clearly technical UI skills oriented. So, and you have to unburden, so to speak, your application developers from all the UI issues. Yeah, so an application developer should say, hey, this is what I want to see on the client side. How it is made possible, this is more or less the task of the person who is doing layout definition conversion into this UI rendering. Well, the great advantage, of course, here is, if it comes to long-term definition, that at this point, with this defined interface, you can really have a break with the software. So if a certain client concept is not working well, yeah, you can change it. Yeah, you can transfer this into another. It really can come, and this happened in our case, but it was planned this way, that we started, for example, with a Java Swing-based client in 2007. Yeah, we even had a JavaFX-based client 2012, but then moved over to a JavaScript-based client in 2017. Yes, which is now our favorite client, of course. Yeah, and the interface here was exactly the same. So the dialog definitions sent to the Swing client were exactly the same dialog definitions which are now sent to the browser client. Yeah, and these dialog definitions are now just rendered by a different rendering engine. Yeah? So you can exchange the rendering engine in the client in front of the application, but you don't have to tell the application if it's compatible, of course. In our case, it's compatible, it always was compatible. And so you can exchange on the fly the server, the client technology without telling the server. And this is a big advantage. Look what happened in the last 20 years with UI processing, yeah, where we came from a really Windows whatever based UI thinking into a web UI based thinking. So what will happen the next 20 years? And are you sure that we are in the browser environment always? This strategy really gives you the confidence that whatever changes on the client side, it is independent from what you do on the application side, on the server side. Yep. Now, this is not a new concept. Yeah, this concept is already known, for example, from terminals. Yeah, well, I don't want to mention them, but I have to. These ugly green-black screens. Yeah, so what was a protocol in the 80s? Yeah, it was a COBOL application, whatever, running in the mainframe. Yeah, and there was a character stream which was sent up to the client, and the client was rendering this line by line by line by line. Yeah, and sending back changes to this data that it sent to the client. So this concept was there, and then you know that the first terminals have been hardware terminals. Then they were software emulation terminals, written in DOS, written in Windows, written in the web. So one and the same terminal, so to speak, survived multi-generations of front-end technologies. Yeah, same with the R3 client, SAP R3 client, and there were also other frameworks. For example, there was a nice one, Canoe, but not too many know it was a Switzerland framework, a nice one. Anyway, what was the big mistake of these frameworks, of these interfaces, I have to say? It was that the technology of the API not only contained the way how things are communicated up and down, but they also fixed or they defined in a fixed way the number of components and the type of components that are transferred. So in case of the good old terminal, it was something like field label, function keys, and these things. And of course, every generation of UI has new components, and it's an inflation of components here. So it's if you try to say these are the 12 components to make an application developer happy, you will always fail. Yeah. So this protocol here has to be open to embed new components. Yeah, and to be open to adapt, so to speak, to future component changes. And that's exactly the difference from nowadays protocols to these protocols. Well, in the 80s, you did not think about graphic components, so it is understandable why this concept was not implanted at this point of time. But that was one of the mistakes, or one of the biggest mistakes of these terminal protocols. Anyway, but you see, from a long-term perspective, the applications running in the 80s, written with COBOL in the mainframe, still run, yeah, if you like it or not. But technically, they still run, and they survived, so to speak, 40 years of software. Well, this server-side dialog processing concept, this rendering client, which is independent from an application dialog definition, this has many advantages as well. So not only this long lifecycle aspect, yeah, it's very efficient to develop. It's a very governed round-trip management between the client and the server side. So the data volume, which is exchanged between both parties, it can be really reduced to a minimum. Yeah. It is a concept to ensure consistency of UI across hundreds of screens. And also it has many security aspects. It has some disadvantages or challenges here, so that it keeps state on server side and these things, but it is worth it to look into this concept in a follow-on. We will not do it in this session, but in follow-on sessions. But it's a very interesting concept. So what do did we hopefully learn out of this session? Yeah. First of all, application life cycles, they are something like decades and not years. Yeah. So we are talking about 20 years and not 5 years. Yeah. In these ones, you have to identify these things which should be kept stable, and these ones where you should say, hey, come on, there's a re-implement after 3, 4, 5 years. There's no need for stability, for eternal stability of architecture. Yeah. Consider the concept of the rendering client, so the layout eating machine, so to speak, on the client side, which is separate from the dialog definition level on the server side. Consider this concept to be part of your architecture, because it's a very strong concept and ensures a long-term stability of a core part of your investment, which are these operationally used UIs. You can build something on your own there. You can use existing frameworks. Captain Carter offers a very nice framework on this. So if you're interested in getting into contact with us, hey, do so. We would be delighted to get to know you. Thanks for watching this video. You see captaincarter.org. That's where a lot of information is available and a lot of demos. Maybe worth it to visit. Thanks a lot for watching.